that include the extra credit problems that we did on the line before this test?
Yeah, what it is it's just the MyMathLab, not the quizzes or anything. It's that, and if you did the reviews for extra credit, that adds into the average, okay? So that kind of can help somewhat. Usually what happens on that is if you did the extra credit, that usually just adds, like if you say you got 100 on all 4 of them, I don't know if anybody is going to do that, but that would wipe out 4 zeros. Okay, so it's like that. So it does add on to it, okay, in that total average. I won't know that until everything's closed on MyMathLab, though. That'll be like next week, okay?
So the last couple of MyMathLabs, since you're not going to be doing the notebook review, you're not going to be wanting to, showing our work or...
No, you don't have to worry about that. I'm not going to do the notebook, so that's fine on that. I'm pretty well done with that, okay? Yeah. Let me go. Okay, so let's go ahead and do this first of all. So you want to know how to do one problem like this. Now I'm going to do, I think I'm going to do this B. I'll set up number 9, but I'll do B, okay? All right, so first of all, basically all you got to know on this is the area is always, you're going to do the integral, and you're going to do the top curve minus the bottom curve. We went over this last time. So I mean, it's doing a definite integral. And what I do on this, since it's the last thing we learn, is I just give you a graph, okay? So really what you would do on this one, I'm not going to work this out, but I will show you how you can do this on your calculator. So which curve is on top? That one, okay? So you do the square root of x minus the curve that's on bottom, x squared. And so you're just having your integral in terms of x, okay? You don't put y in there, it's just those x, dx like that. Then I'm given problems pretty simple at this level of a class where you're basically going from 0 to 1, okay? You'll be able to look at that visually and tell, so that's going from 0 to 1. Okay, now on the problem that I do on the final, I have you do that by hand, but you can check on your calculator. And I'm not going to do this one. I'm going to do the next one, and then I want to just remind you how to set that up, but I'll post that, later today then. So let's set this one up. Let's do this one together. All right, so again, we do the integral, and the curve that's on top is the parabola, so that is 5x minus x squared. The curve that's on the bottom is the line minus x like that, okay? So I have that, and then where do I integrate from? What does it look like to you? 0 to 4, actually. It's where those things intersect. So you got to make sure that you know where they intersect, say. Okay, if you go to 0 to 5, you're looking at something that's outside of that shaded region like that then, okay? All right, so what we end up having is, now this one would be about the level that I'd want you to know how to do. We have negative x squared. These are like terms, so that's plus 4x times dx like that. Okay, so that's the setup right there. And on an exam, you get credit for what you do. I mean, that's part of it. It's just doing the setup correctly. Okay, right, now what we're going to do is do the antiderivative. Okay, and this one's pretty straightforward. So the antiderivative of negative x squared, what's that? Negative x to the third over 3. Okay, how about the next thing? 4x squared over 2, okay, like that. That's power rule. And then I usually put the bar 0 to 4, then we got to evaluate this. Now, you can use your calculator to certainly help you with this and everything. So what we would do from here then, I'm just going to move everything over here, plug in the 4, so you would have negative 4 to the third over 3. See, 4 over 2 is 2, so you want to simplify that. So that would be plus 2 times 4 to the second, like that. Okay, you like it if I give a 0 in the problem, because that makes it easy. So that'd be negative 0 to the third over 3 plus 2 times 0 squared like that. So that's how you set up the definite integral with calculus. You evaluate the upper limit, the lower, and then subtract the difference, okay? And if you did this part right here would be negative 64 over 3. You could use your calculator if you had to on that. This one right here is 2 times 16, so that's 32. How about all this stuff with 0? Can you see that that's all going to be 0 anyway? Okay, so if you can, you don't have to show the details of that. And then you would want to get a common denominator. You can even use your fraction aspect of your calculator to work that out. So we'd have negative 64 thirds, and then that would be 96 thirds, like that. So then you get your answer to your problem, and that would be an exact form, like this, and that ends up giving you 32 over 3, okay? So that answer is 32 over 3. Okay, now there's the arithmetic aspect of that, and then there's the calculus part of that. Now, one thing I'd want to remind you of when you're doing this, let me pull my calculator up, because we spent, some time in class going over how you can check integrals, so I want to do that just one more time on here. So what I would want you to be able to do on a problem like this is set up the integral, do it by hand, but by all means, check. Check and make sure you're right. Okay, so what you would do on this is you would put in this thing right here. You would want to graph this. That's the integral that you're doing, okay? So you would want to put in negative x to the second, and then plus 4x. Now, this is not going to give you the graph that I gave you. This is different, okay? And then you can probably do that even in a standard window on this one's probably okay. You could go zoom 6. Again, that doesn't give the same graph, but what you do now is you go second, calc, option 7, and the integral is going from 0 to 4. So that gives 10.6, okay? Well, notice what happens on that is if that is 10.6, our answer was what, 32, what was it, 32 over 3? Yeah. So if we just go 32 over 3, it's the same thing, okay? So I know I'm right, okay? So you got the ability to check and look and make sure you're right, okay? So you want to know how to do that. Now, that's straightforward, that you're given a graph and being able to find that area between the two curves. The next one I'm not going to do, but again, you would have to do the integral the way I just did, and then you could check it on your calculator. Does that make sense? Is there any questions? Are we good? Okay, all right. Does everybody have a copy of the final exam review? I got more up here if you don't have one. Okay, all right. Okay, so let's kind of move around from here then and do a couple of things here. Let's go to 17. I'm going to jump around a little bit and do some stuff. We'll have time to do, I think, most of these things, and I'll just kind of jump around. So we want to make sure that you know what's up. The review? Yes. Yeah, I got several. Does anybody else need a copy of this? Okay. I was late in putting this up, so I went ahead and printed this out. You need one? Okay. Okay, so the other thing you want to know how to do is use rectangles to estimate, okay, an area under a curve. Now, we know how to do the exact area under the curve, but I want you to know how to do the estimation. So the way I'd go about doing a problem like this, first thing I'd do is just graph this. You got your graphing calculator, so you can graph that. So I'm going to put in 8 minus 0.5x to the second. I'll just give you some kind of a curve that's pretty easy to graph. And for a window, we're going to graph from 0 to 6. Now, one thing on a graphing calculator, it's always pretty important to go a little bigger than that endpoint, because sometimes the graphing calculator will mess up a little bit. So I'm going to go like that. For your Y window, I sometimes wonder if students spend too much time on a test figuring out the Y window. What I've been showing you is go to your table of values and just look at how the Y values change. It looks like it starts at 8 and it goes down. Okay, so that means a good Y would probably be something like 0 to 10, scale by 1 like that. So that's a good way to get the graph set up, is like that. Then you can graph on your calculator and get that. So what I would be looking for as far as the graph is accuracy. And I see that with a lot of students. Sometimes it's just draw the shape, okay? That's meaningless. You have to show me the x-axis, what everything represents, and maybe do 2 or 3 points for accuracy. If you get 2 or 3 points, then you're going to be good. So let's just kind of go like this. That's 2, That's 4, that's 6, that's good enough. You can make it bigger if you want to. And then we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's kind of up to you how you scale that, but you got to show those numbers. If you don't show those numbers, your graph is nonsense. I mean, just putting it mildly, okay? All right, so what I'm going to do is let's look at the table of values. Okay, we can plot points, so we can get this perfectly accurate. So we can graph 0, 8. It's not a bad idea to label that point. I'm going to go 2, 6. Okay, and then I'm going to go, let's go 4, 0. Oh, crap, I didn't mean that problem to work out that way. Yeah, that's okay. Let's go ahead and just roll with it. I think we're okay. We'll have a region under the curve, which is okay. So we have 4, 0, and then we're going to go to 6, negative 10. We might as well just go ahead and run through this then. So this is going to go all the way down to 6, negative 10, kind of like that. Okay. Then what you'd want to do is you would want to sketch in that graph kind of like that. Then it's okay if part of the region's under the curve. We looked at that. I think typically I try to on a test just try to keep it fairly simple with the region above the curve like that then. Okay. All right. So what I'm going to do from here then is we're going to do right endpoints like this. So the first thing is what I say on here is 3 rectangles. That's as much as I'm going to give you. It's just kind of redundant if you get more rectangles. So one thing that you want to remember how to do is delta x is b minus a over n. All that does, that gives you the width of the rectangle. And you can do that in your head a lot of times. So a is 0, b is 6. So you go 6 minus 0, n is the number of rectangles. So 6 over 3 is 2. Okay, and you'll be able to bring in the half sheet of paper like you've been doing. And any formula you need to write down, you can. If that's one you need to write down, you certainly can. So what that means is the base of each rectangle is 2 units. And height is going to be a right endpoint. Okay, so you want to study how this goes. So basically what we're going to do is we're going to go over 2 for that base. Then we're going to go up to the right endpoint, and we make the rectangle, the height would be that. That would be the right endpoint like that. Okay? If I set a left endpoint, then the rectangle would be all the way up to there, see? Does that make sense? I don't care about anything on the final other than right or left endpoint. I don't care about midpoint. We did that in class. So if I said left endpoint, then your rectangle looks like that. Okay? All right? Then if you go to the next one, and this is where it's weird. This is a weird example, but it's still okay. Then this one, the right endpoint would be there. So you wouldn't even have a rectangle, right? Which is okay. I mean, it doesn't matter. Okay? So we would end up having this rectangle here. It's actually nice if you don't end up with a rectangle because what's its area? 0, right? That's cool. That makes the problem simpler. It really does. Okay? All right? And I'm going to redo this problem in just a minute with a left endpoint also. So now what we do is we go down here. So we go all the way down like that, and then you draw around like this. Okay? And it's okay if that area ends up being below the curve. You end up doing that. So the idea is the base is 2. That's what that did. The right endpoint is the height. So that height would be 6. That height would be 0. That height would be negative 10. Okay, does that make sense to everybody? Okay, all right. Now, when I have you do the area, you can just figure out the area of the rectangles. You don't have to write all the notation I was showing you. So if you want to, you could just say that's region 1, that's region 2, that's region 3. So the area is just going to be the area of region 1 plus area of region 2 plus area of region 3, okay? And it goes like this. It's base times height. The base is 2. What's the height of rectangle 1? 6, okay? That's the benefit of getting those points, so that's 6. Region 2 is the base is 2. What's the height of region 2? 0, okay? That has no area. And then you go to the next one. It's base times height. What's the height of this? Negative 10. Okay, you guys see what I'm doing? The right endpoint function value gives you the height. That's arithmetic. So what you get here is 12 plus negative 20, so it's negative 8. Does it make sense to you all that you would get a negative answer on that? Why are you getting a negative answer? Because there's more area below the x-axis, exactly, and that's okay, right? Okay, so you can have a region below like that. Now, I'm not going to redraw the diagram for a left endpoint because it's almost the same anyway. So what's going to happen on the left endpoint is you're still going to go base times height. So now it's going to be 2 times 8, then it's going to be 2 times 6, and then the next one's going to be 2 times 0. So what you're doing is left endpoints, and you don't have to redraw the diagram. I'm just going to highlight those left endpoints right there. And what you would end up getting if you did left endpoints is it would just be 2 times 8 plus 2 times 6, and then it would be 2 times 0. Okay, so that would end up giving 16 plus 12, so that would be 28. So you want to know the difference between left and right endpoints. All I did on the left endpoint is if I drew the diagram, this rectangle would be way up like this, and then like that, and then the last rectangle would have no area. Does that make sense or not? Say something.
Yes.
Okay. You know, base times height, that's what I'm doing, okay? And the function value is always the height, okay? So you want to make sure that you know the difference between when I do left and right endpoints, okay? I think the one that's on the final, I think everything's above the curve. That makes it a little easier for students, I think, to understand, but that's the idea. You're given a curve, no more than probably 3 or 4 rectangles is what you got to do, okay? All right, now how do we find the exact area? Well, we do the integral, okay? So what we end up doing on this is we just do the integral. So I always like on these problems to kind of have you do the estimation and then be able to get the exact answer using an integral. And you're going to integrate that from 0 to 6. And you would want to work this out by hand. But again, you could check on your calculator by doing the feature that I've shown you to do on that. Okay? All right, so what's the antiderivative of 8? What? 8x, good. How about the next one? 0.5 x to the third over 3. Okay, got that. And then we're going to evaluate from 0 to 6 like that. Okay, so it's kind of like the area between the curves problem that I did. Okay, so what do? You plug the 6 in first, so you would have 8 times 6 minus 0.5 times 6 to the third. You'll be able to use your calculator. And then you got the 0 thing, which kind of helps speed up the process. You'd have 8 times 0, 0.5 times 0 to the third. Whoop. And then all over 3 like that. And then that's what you'd work out. And you can do that all on your calculator. So it looks like this is going to give 48. And if you get a decimal, that's okay, because you can convert decimals to fractions. I'm going to show you, just remind you how to do that. So if I go 0.5 times 6 to the third, you can do that in one step. And take that and then divide that by 3. I guess that'll turn out to be a whole number, which is kind of nice. So you end up getting 36. How about all this 0 stuff? Do you guys see that that's all 0 anyway? Okay. All right, so that means the answer is 12. Okay, so that's the exact answer, and these are just estimated answers like that. And what will happen is the exact answer always ends up being between those two things. Okay, so you should, and you can check that on your calculator by, if you graphed this, if you put that in Y1 on your calculator, 12 will come out if you use that feature I've taught you. Okay, are we good? Okay, areas base times height. You got to know the difference left and right rectangles. And you got your calculator. Okay, calculator will help you. Any questions? Okay, good, bad? Okay, all right. I got a sign from one guy back there. Everybody else okay? Okay, all right, okay.
I'm just barely hanging in.
That's what it is, Jay. That's right. Okay. Let's look a little bit at, while we're kind of on the subject of integrals here, let's look a little bit on this page 10 and do a couple of things with this. I want to go over a little bit of U substitution, and I might add something to this 2. Yeah, let me go through this 16. Some of these problems I took just out of the notes. You'll probably, if you went back to your notes, you'd find a lot of these same problems here. So you want to make sure that you know how to do this. This is just seeing that you understand basic properties of integrals. So see, I'm giving you 3 different integrals evaluated on different intervals, and then we're going to use that information to find this. Now, you're not working this out, okay? You're not going to like work it out. You're going to use what I gave you. So what you're kind of looking at on this is, you know, you can bring the 3 out, so you have 3 times the integral, 1 to 4 x squared dx like this, okay? Now, what I did is I gave you what the answer to this integral is. So there's really nothing to it. I gave you the integral of x squared from 1 to 4 is 21. So what do? You do 3 times 21 to get 63. Okay, so you want to know how to do this. The whole point of this is, do you understand how to put together integrals when you do that? Okay, this one you would go like this. Now you got 2 things subtracted, so you put it together like this. You would say 7 times the integral 1 to 4 of x dx, and then minus 2 times the integral x squared from 1 to 4 dx like that. Okay, now you can, as long as you do show me on the paper that you're doing the arithmetic, okay, then that's fine. But technically, that's the property of integrals we learned how to do. So you got to learn how to break it up. So if you look at this, it looks like I gave you that the integral 1 to 4 of x dx was 7.5. And it looks like I gave you the integral 1 to 4 was 21. Okay, then from there, you just do it on your calculator. So 7 times 7.5 minus 42 would give you 10.5. We did these same problems in class. Okay. All right, everybody with me there? Okay, all right. So the next one here, what you have is you're going 1 to 5. So what you have to do on this is you have to break it up like this. You have a constant that comes out. Then you have to break it up into 2 integrals. So you would have to do the integral from 1 to 4 of x squared dx, like that. Then you would have to do the integral from 4 to 5 of x squared dx like this. All right, and that's what you end up working out. So the idea is if you're going from 1 to 5, you got to go 1 to 4, then 4 to 5. And then again, all these things I gave you. So this integral right here was given as 21. And then this integral from 4 to 5, that was given as 61 over 3. So then what you would do is you would just do minus 4. And that 4 minus 4 is times the sum of those. So you have to have a grouping symbol. So you go like this. And see, this one right here you can do on your calculator. I mean, you don't have to show everything. So you can just go -4 parentheses 21 plus 61 over 3. That'll give you a decimal answer. And now, you guys remember how to change that back to a fraction? I hope you did that a lot during the semester. You just go math, fraction, it'll give you the answer. Okay, so you can take advantage of that. Okay, but I want an exact answer on these things too, but you can use the calculator. Okay, just get the decimal and convert it. Okay, all right, what's the answer to the next one? I didn't put that on the final, should I? That's the easiest one. If it's an integral from 5 to 5, there's no area, right? Okay, I just threw that on there. But the ones that I just did, those first 3, you want to know how to handle that kind of situation, okay? All right. Okay, questions on that? Okay, let's go to the top of this page. And I'm going to work, I think, I'm going to make a slight change to 15a because I meant to do like a definite integral on here. So I'm just going to do something like, let's just add in something like 0 to 2. Like I use 0 a lot just for a test, just because it saves time. So we're going to do this one by u substitution. So this is not an integral you can do in your head. So do you know what I would set u equal to in this problem? There you go, good, right there, okay? So, we kind of review the U substitution, so that's x to the 6 plus 2. What I saw on the third test was a lot of you, I could tell almost everybody knew how to figure out what U is, but a lot of you didn't know what in the world du was. So what is du? It's the derivative of u, right? Okay, so that would be 6x to the 5th. What else do you have to put? Okay, so I take off half of a point on that if you don't put dx because you're wrong. Okay, so you have to have that then. Okay, now what we've learned on this then is we kind of hope the du is what's left over. So it is in this case, so it makes the integral quite a bit easier. So our integral would end up being u to the 8th, and then 6x to the 5th dx is du. That's an integral that you can do, okay? Now, we did this in class. The limits, you have to change the limits because you want to make your integral as easy as you possibly can. So let's review that. So the upper limit is 2. All you do is just plug that into the u substitution. The u substitution is this, so you would work out 2 to the 6 plus 2. And you can do it on your calculator if you want to. I think that's 34 maybe. Or no, that's 2 to the 6 is 64, so that would be 66. Okay, so that means that limit changes to 66. It's a big number, but don't worry, you get to use your calculator anyway. Okay, and then the lower limit of 0, again, you plug it into the u substitution, so that's 0 to the 6 plus 2, so that's equal to 2. So that's the integral you're going to do. All right, are you with me? Okay, you have to change the limits. If it's a u substitution definite integral, you have to do that. So just plug in the 2 to the u substitution. Okay, now the integral's easy. What's the antiderivative? U to the 9th over 9, right? You're going to evaluate that from 2 to 66. You can use your calculator, okay? Now, since that's a 1/9, the way I would do that is just write down the 1/9 and then evaluate 66 to the 9th. That's going to be 66 to the 9th minus 2 to the 9th. There's no telling what kind of crazy answer I'm going to get on this. I just made the problem up. That's probably not a good choice. So if I do 66 to the 9th, I get something in scientific notation. Let's stop the problem there. How about that? Okay, that's good enough. I mean, actually, I would never probably on a exam give you a problem. When I did 2 to the 66, I got 2.37 times 10 to the 16th power. Okay, this has got a major area under the curve, so I'm not going to worry about that, okay? All right, I wouldn't make a problem up like that, but I want you to know the point of how you would do that then. Is that fair and good enough? Okay, all right. I probably should have made it 0 to 1. That probably would have worked out a lot better. All right. Okay, let's do this next one with u sub also. And I'm going to add on this one too. I'm going to do the 0 to 1 on this because I want to make sure you know how to do this. If you know the u sub part, you also got to do this part here. All right, so what do you think I should set u equal to? T to the 3rd. See, if you have e in your integral, the only thing that you know how to do the integral of e to the u, right? Okay, so it makes sense that this part right here should be your u so that you end up with e to the u as your integral, okay? So I like to, when I'm teaching this, highlight what you're hoping du will be. You're hoping du is t squared dt, but it isn't. It doesn't matter though. So what this is that's 3t squared times dt. Don't forget that dt, it's important, okay? Now, what do you need to do to change the 3t squared into just t squared? Divide by 3, good, okay? So you divide by 3, that means you're really multiplying by 1/3, okay? That's how you adjust that then. So what's going to happen is you're going to have e to the u, and then the part I've highlighted in blue is going to be 1/3 du. Well, you like that integral, though. What's the integral of 1/3 e to the u? It's 1/3 e to the u, okay? So you got that. Now we got to change the limits, okay? So this is the other thing I wanted to review on that. The upper limit was 1. Where does that go? It plugs into the u sub. So I think this one's going to work out beautifully. It's still 1, okay? All right? Nothing's going to change on this one. I do the 0. Again, I plug the 0 into the U sub, so I still get 0. Sometimes they change, sometimes they don't. You just have to find out. So what you would end up with then is you would end up with the integral from 0 to 1 of 1/3 e to the u du. Okay, so that's how everything gets put together. All right, that's as simple as it's going to get too. So what you would have is 1/3 upper limit. You'd have e to the first minus e to the 0. So you'd have 1/3 e to the first is e to the 0 is 1. So that's a good answer. And that's exact. You don't need a decimal, that's exact. Okay? So that's something that I kind of, based on looking at the test 3, I could tell a lot of you have struggles with U substitution. That's pretty common. That's one of the areas of integration that's a little harder for students to learn. Okay? So you want to know how to handle those situations. Okay, how do you feel? You feel good? Okay, no? Yeah. About the what? Okay, the thing is, when you do du, and that's something sometimes students struggle with, you got to work on that a little bit. When we did this was 3t squared dt. Okay, that's supposed to end up being t squared dt. So the way we make it turn into t squared dt is we just get rid of that 3. So we divide by 3 like that. You can write it either as du over 3 or 1/3 du. So now when we plug in, we have e to the u, and then this whole thing right here is 1/3 d to the u. See, if the du doesn't match the remaining part of it, then typically you have to get rid of that number somehow. Okay, then everything's accounted for. That's it. Okay, that's the other issue that you got to make sure that you pay attention to. Okay. All right. So let's see. I've done a bunch of integrals now, so let's kind of go up. Yeah, we definitely want to do 14. Okay. All right. So let's see, with this, the idea on this, and I think the test 3 that you did, there was a problem that was real similar to this in concept. So what this one is saying is you're given basically a rate. So it looks like you're given, this is the number of subscribers, but that's a rate. And what you're trying to find is C of t. So if I give you a derivative, C prime, how do you find C? You do an integral, okay? Okay, so if I give you a rate, you got to integrate to get the original function. Okay, so the first thing you got to do is C of t is going to be the integral -600 t to the 1/3 dt. I'm giving you a marginal or a rate of change, so you have to integrate to take it back to the original function. Okay, that's not a U substitution integral. That is a basic power rule integral. So step 1, we need to do that. You can bring the -600 out, or you can bypass this step if you want to. Okay, so let's do that. Okay, now remember what you do. I see students have trouble with this sometimes. You're adding 1 to that, so it's really 3/3. So you get 4/3, right? So you divide by that result. Now, how do you handle the divide by 4/3? Multiply by 3/4, exactly. Okay, so you would end up getting 3/4 times t to the 4/3. So that's the antiderivative, all right? And you got to put your plus c. Okay, remember, you put a plus c if it's not a definite integral. So like if you don't have limits on the integral, then you have a plus c. So your antiderivative is -600 times 3/4 t to the 4/3, and then plus c like that. Okay, so that's where you start the problem. We still have several things to do then. Okay, so the next thing it says, and I guess we can go ahead and simplify this. You could take your calculator and just do this like this if you wanted to. You can go, let's see, -600 times 3 is -1800, and then you can divide that by 4. That'll simplify it a little bit. So it's probably wise to write this as -450 t to the 4/3 plus c. All right, you guys got any question about what I did? Okay, that's power rule. Power rule is something you want to have down for your integration. Now we have to find c, though. Okay, so it says there's 64,000 subscribers at the beginning of time. So that means you have a point, 0, 64,000. So you use that to find c. Now c you can actually do in your head on this problem. I'm going to show you what you would do. So basically, you would replace the c of t with 64,000. That's the number of subscribers at the beginning of time. Well, the beginning of time is 0. Okay, so you have that equation. Can you tell me what c is in your head? I hope you can. Yeah, okay, because see this, and you got your calculator. I mean, anytime you take 0 to any power, it's 0. So you end up getting c is equal to 64,000. Okay, like that. All right, so that means that what you would get, there's two parts of this problem. The first thing would be, this is kind of like part A, you would end up getting c of t is equal to negative 450 t to the 4/3 plus 64,000. So that's the answer to the first part of the problem. You did this. On your test 3, you had a problem, same thing with this. And then there's a second part that we have to do as well. Okay? All right. Are you guys with me? Okay. All right. Now here's the next part. Now this is the part that I know a lot of students would not know how to do the algebra. I see that all the time. This says, how long will it take until the number of subscribers drops to 46,000? Okay, so here's what you got to do. All right, what are you going to do with that 46,000? That's what C is, right? So you're going to replace this with 46,000, and then you're going to solve this equation. And there's a lot of students, I think, in this class who don't know how to solve this equation. So you want to study this and make sure you know how to do this. Okay, so we're doing that. We're going to find the amount of time we're solving for t when that happens. Okay, and I'll show you the simplest way to do this. First thing to do would be to subtract 64,000 from both sides. So you'd want to do that. So 46,000 minus 64,000 is negative 18,000 is what I got on my calculator. So I've got negative 18,000 equals negative 450 t to the 4/3. Of course, that cancels out. Okay. Next thing you got to do is get rid of the 450. So you want to divide both sides by negative 450. And take your calculator and just do that. That's 18,000. Hold on. Yeah, that's right. 18,000 divided by 450. That's 40. Okay, so I kind of got nice numbers on this. Okay, students usually know how to get to that point, but then don't know what to do with this. Do you guys know what to do? It's one step and you're done. Okay, you raise both sides to the reciprocal power. And what you have to understand on this, if you did t to the 4/3 raised to the 3/4, you multiply the exponents. So you'd have t to the 12 over 12, which is t to the 1st. That's why you do that. Okay, I think a lot of students have never seen this in their algebra background. That's why they don't know how to do that. So you do that to both sides, and be sure you study over how to do that, because this shows up a lot. Then you can go to your calculator. The rest of it is just go 100% to your calculator. Just do 40 raised to the 3/4 power. I'm not going to go over how you do that by hand, so you would end up getting that value like that. So that's about 15.9. I think or I don't know if that's days or year. No, it said months. So the problem says months. Okay, like that. So that's kind of an important problem. That's one of the more important applications of integrals you learn in this level of a class. Okay, the idea of doing area and then just being able to work with functions like this. Okay, that's how that goes. So be sure you study how to solve an equation like that. Okay, all right, that's the idea. Any questions? No? I heard a yawn. Is somebody yawning? You are, Reagan. All right. So if you have a problem with insomnia, now that you've been a student of mine, you can go to YouTube and watch one of my calculus videos. It'll probably put you right to sleep at some point in time. Okay. All right, let's see. I think the integral is probably not going to do too much on these. Definitely want to do this. This problem right here we have done so much in class. It would be my hope that students just have this down. If you're a business major, this is kind of like the big thing you want to have down. You don't want to have to write down any formulas or anything. So let's go through this. You want to know this. This was on the last test. I don't remember if this is the same problem we did on test 3 or it's real similar to it if it's not. So let's do this. Then we'll do a short break here. Then we'll get into some of start kind of going back through the limits and some of the derivative applications. Okay. All right. So let's see. How do you find a revenue? X times P. How do you find a profit if I ask you about a profit? Oh, people are saying it in unison. That makes me feel good. It's like an exit competency of this class. You're a business major. You have to know those things, right? Okay. So actually, the revenue function, all you do is you just take the price function that I gave you. That's called a price demand function. If a student wrote it this way, I wouldn't count you wrong because it's right. It's just you want to go ahead and multiply it out because you're going to have to do the derivative in a minute anyway. So you'd have the revenue is 200x minus x to the second over 30 like that. Okay. So if you're given a price demand function, that's how you find the revenue. Okay. Now what we're doing is we're finding the maximum revenue using calculus. So what do you do if you're looking for a maximum? You do a derivative and then do what? Set it to 0. Exactly. Okay. And that's going to be good enough because you can check on your calculator. If you graphed this function on your calculator, it would verify whether you got the maximum right or not. Okay. So what we do is we do the revenue. The nice thing about these problems is the derivatives are easy. So the derivative of 200x is 200. The derivative of the next thing is 2x over 30. And again, 30 is a constant, so you just write it down. And then you can either leave that alone or you can reduce the fraction. That actually reduces to 1/15. You can even change it to a decimal if you wanted to. It doesn't make any difference. I'm just kind of curious what that would be. Yeah, the decimals repeat on that, so I'd kind of leave that alone. So you have 200 minus x over 15. Okay, so that's your revenue. Then again, you set it equal to 0, so you just say 0 equals 200 x over 15. So I think on the test 3, I saw a lot of people getting a correct derivative on this, but then algebra started falling apart. How do you solve an equation like this? Well, you want to get all the x's on one side, numbers on the other side. So you could move the x over 15. It'd now make that positive equals 200. Okay, then what? Multiply by 15 or cross multiply. It doesn't make any difference. Okay, so you can multiply by 15 to get rid of a fraction. You want to get in your mind that generally, if you have an equation with a fraction, get rid of the fraction. So if we do 200 times 15, that gives 3,000. I think that's the same problem I gave on the test 3. Okay, is that the revenue? Is that money? No, that's not money. What does X represent? You have 3,000 television sets. So that's not the answer to the problem. That's not the revenue. So what you would have to do, that's the number of cameras that produces the maximum. So where do you find the revenue? You can either graph or you can actually go to your revenue function, which is the answer to part 1, and you just plug into the answer to part A, which is 200 times 3,000 minus 3,000 to the second over 30, and you can do that pretty much in one step, like that. So I'll just go 200 times 3,000, and then 3,000 to the second, and then over 30. Okay, so that gives 300,000. So that's the money amount. That's the maximum revenue like that. Okay, all right. Okay, and the last question is, what price do you charge? So what do you need to do there? Yeah, but you got a price function, right? Okay, your price function was given as 200 minus x over 30. So what you do is just plug in the 3,000. So you'd have 200 minus 3,000 over 30. You put that in your calculator, and that gives you the optimum price that will maximize your revenue. So 200 minus 3,000 divided by 30, and that gives $100. So that's it. Okay, now you want to make sure you know how to do that. I mean, that's kind of a big problem for a business calculus class. Okay, I tried to pick out the biggest, most important business applications because that's the kind of stuff you might see a little bit more in the future. Okay, everybody got that down pretty good? Okay, all right. Okay, let's take like a short break here just for 5 minutes, and we'll come back and we'll kind of see how much more of this we can get done, I think, for business students. Okay, so we're going to look at point of diminishing returns. I'll just use the example we did on the third test here. Okay, so basically what I want you to be able to do on this is graph this, and the purpose of the graphing is so that visually you can see if your answer is right. Okay, that's the purpose. Okay, on test 3, there was some not really the best graphs. Some of them were great, some of them they weren't even graphs. So I'm going to put this in. 10,000 minus x to the third. And plus 45x to the second. You want to make sure that you're a good graph drawer. And you got technology, so, you know, technology can get everything done for you. The key thing for you is to make sure that you know how to set up a window. I don't tell you a window, but I tell you the most important thing. I think some of you, I can't remember on this. This one we're just going to 20. So for a window, we want to go 0 to 20. You can scale by whatever you want to, so I'd probably scale by 5 like that. Then again, for the y's, I can tell a lot of students still don't understand how to figure y out. Just go to your table of values and look at the values. The values are up in the tens of thousands. Okay, so it looks like when I get all the way to 20, I'm at 34,000. So for that reason, a sensible way to do this would be maybe go 0 to, how about 35,000 or 40,000? It's your call. Maybe scale by 5,000 or something like that. Okay, so that's a good way to get that put together, is to do that then. Okay, so there's my window, and then I'll graph this. And again, what I'm looking for is maybe 3 points. Okay, and you got to scale everything. I think some of you didn't even do that on here. Just get this set up, so however you want to. I'm going to go 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. Try to take up as much room as you can. 1, 2, 3, 4, 5. That'd be 15 out to 20. And then however you want to do the 5,000s, I don't care. I'm just going to go every 10. You can even go like this. 5K, 10K, 15, 20, 25, 30, 35. Whatever you want to do there. But you got to label at least some of those things. Okay, like that. All right. Then what you want to do is just get probably 3 good points. If you get 3 good points, that's good enough. I would just use the trace feature or the table of values. It doesn't matter. So if I go to the table of values, the first logical point to be would be 0, 10,000. So I would just do that and label it. If you label it, it makes me happy. It makes it easy to grade. So that is, you could put 10K there. That's your first point. Then I'd go to 20. You can either look at your table or you can use the trace feature that I've shown you, and that's 34,000. Okay, so get that accurate then. Go over to 20 and up to close to that, and if you label that, then we could just say 20 and 34K like that. Okay, then I'd probably get one more point. What I would do is I would get the point of diminishing returns once we get it. So for now, that's good enough. Okay, I'll connect it in a minute. Okay. All right, so tell me how you find the point of diminishing returns. Second derivative, set to 0. You're looking at an inflection point. You're looking at where the concavity changes. Okay, So what you need to do on this is you got to do the second derivative because you're looking at an inflection point. So the first derivative is negative 3x to the second plus 90x plus 700. Okay, remember you're looking for analyzing the second derivative on point of diminishing returns. Second derivative is negative 6x plus 90. So nothing real complicated or time consuming. Now what do I do with that? I set that equal to 0. Okay, like that. Easiest way to solve this would be to isolate the x, just move the 6x over, divide by 6. Take your calculator if you need to, so you get x equals 15. Now the other thing is, I say point of diminishing returns. That means I want a point. I don't want just 15. Okay, 15 would be how much I get, what x represents. Now what you do here is just use your calculator. I'm having you graph anyway, and you could look this up on the table of values, and there you have it. Okay, so it would be 15 and 27 to 50. Okay, and then what I would do is I would just plot that. So on my graph, I go over to 15 up to about wherever 27 is, somewhere in there, just estimate it, and then maybe label it. Okay, and what happens on this graph is it does something like this, just kind of sketch in the shape. So it kind of does something like that. And actually what happens, I mean, you don't have to do this on your paper, but you're concave up there, then you're concave down there. That's what happens. That's a point of inflection. That's what a point of diminishing returns is. It's a point where the revenue it continues to increase, but it increases at a smaller rate. That's the idea. There's nothing to finding a point of diminishing returns if the second derivative is easy. Okay, that's it. All right, you guys with me? Okay, that's kind of an important thing for a business student to know how to put together. Okay. All right, let's do a tangent line. I think I'll do 8b. So let's go to 8b. I just put a couple of these on here. That's another kind of big thing that we learn how to do in calculus, is how to do a tangent line. That's just a big deal to me. Okay. All right, so if I want you to find an equation of the tangent line, what is the formula that ultimately gives you the answer? That's a good question. Silence. This one.
That's the one.
That's the one.
You nailed it, man.
Okay, so you need to know that. Okay, we did it. If there's anything in this class we did a bunch, it seems to me like we did a lot of equations of tangent line, because that's a big deal in calculus. Okay, all right. So what you have to know is you got to know this, this, and this. You got to figure out those things. I gave you enough to figure those out. So the first thing I'll do over here is let's just do f of 0. Okay, I gave you x is 0, so that's going to plug in there. Okay, and we just plug into the function. So the function is e to the 3 times 0 plus 1. Okay, no heavy arithmetic on that. That's 0 plus 1. That's e to the first, so that's e. And that's what goes in there. Okay, so you have a point 0e. Don't use 2.7, use e, because we want it to be exact. Okay? All right, how do you find the slope? What do you have to do? Derivative, right? The slope is the derivative of that function. Okay, that's what a derivative is. It's a slope of a tangent line. So we got to do the derivative of e to the 3x plus 1. How do you do the derivative of e to a power? Two things. Itself, then what? Derivative of exponent, right? So this derivative would be itself, you can do this in your head, times the derivative of the exponent. That's the chain rule. That's how it works for an exponential function. So the derivative of 3x plus 1 would be 3. So you end up getting 3e to the 3x plus 1. So that's your derivative. Okay? Now, what do I do with that derivative? I gave you x equals 0, so that's real important, isn't it? So what you do is you do f prime of 0 to find the slope. Okay? So you plug in 0 into the derivative, and that will give you 3e to the first, or just 3e. So what goes in there is 3e. okay, like that. Okay, so you got to know the different derivative rules we learned, not all of them, but some of the main ones, exponential, logarithm, product rule, quotient rule, all that kind of stuff like that. So that's how that gets set up. So it would go like this. You would have y minus e equals 3e times x minus 0. You need to solve that equation for y. So if you do that, you would have y minus e equals 3ex. Of course, x minus 0 is just x, and then you could add e to both sides or move the e, so you get y equals 3ex plus e. That's your equation of your tangent line. Okay, so the thing is, if I ask you for equation of tangent line, you got to know the formula. If you don't know it, use that on your allowed note card, and then you got to figure out those things. I always have to give you what x1 is. I have to give that. The rest of it you figure out, okay? And then this one, on the graphing calculator, I'm just going to put this in. You don't have to necessarily draw a graph on this, but you go y equals e. E is above ln, so you do e to the 3x plus 1. That goes in like that. And then in y2, I would put in my answer, okay? The letter e is above the division symbol, so you can go 3e x and then plus e. And if you do that in a standard window, I think this one will probably graph fine in a standard window, you could visually see if you're right or not. So you would want to get those two things put in and then just graph in a standard window. That's not very good. That viewing window is not very good. Oh, I didn't do the zoom 6. So there we go. That looks better. Okay, you can tell it looks right. Okay, and I'm not going to go over the graph on that. You could put that in. So again, you're doing the graph of the function, the graph of the tangent line in a standard window. You can tell that looks the way it's supposed to. You can tell that that's a tangent line at that point right there. Okay? Everybody with me? Okay? You don't know how to do a tangent line for some function. Yes. You have trouble with your calculator? Okay. Did you get your two functions in? The E is like above the division symbol too. So yeah, if you're looking for just the E, there's pi and then there's E. That's what I did. So I just used a division symbol when I did that. Okay. Okay. Let's do some derivatives. Let's do a little bit of a derivative overall review here. All right, and again, you know, if you study the problems on this, you'll be okay. There's a lot of derivative rules I left off, like the derivative of 10 to the x, or the derivative of log base 5. I don't worry about that. But quotient rule, chain rule, product rule, power rule, logarithm, exponential, those are all real important derivatives. So let's look at a couple of these. And just kind of let's do these right here because they're a little bit harder. Okay, so on part A, what rule applies to this derivative? Quotient rule, right? Okay, so you got to know the quotient rule. Okay, so we go bottom, x to the second minus 3 times derivative of top, which you're more than welcome to do in your head. Derivative of top is 3 minus the top times derivative of bottom, which is 2x, and then it's all over the bottom squared. Don't forget that. A lot of times I see students, they want to ignore that part of the problem and put it in at the end. Don't do that. Just keep bringing everything down, okay? And probably the level of difficulty of derivatives on the final are like medium, okay? Most of the real complex ones are kind of left to homework and stuff. So if we do this, distributive property, so that would be 3x squared minus 9. Be real careful when you do this because of that minus. So you have 6x to the second, but you have a minus right there. So you got that. Then you have 5 times 2x is 10x, but again, that's a minus because of that symbol right there. And then you have all over x squared minus 3 to the second like that. Okay, then it's just a matter of collecting like terms, so you would end up getting, doesn't matter what order you put this in, so those are like terms, so that's negative 3x to the second. and you get minus 10x minus 9 all over x to the second minus 3 to the second, like that. So that's just kind of a basic quotient rule problem like that. Okay, so you want to definitely make sure you know how to do quotient rule. Okay, all right. Nothing real heavy either with a lot of heavy simplification. That's probably a good example. How about the next one? How do you do this? There's two ways. Not product rule. You could do quotient rule. What's another way? Chain rule, exactly. So if you want to, now you could use quotient rule. You'll still get the same answer. I don't care. But you could just say, okay, I'm doing the derivative of 5 times 1 minus x to the negative 10 power. That's how you would do it. It's easier to do it without the quotient rule on this one. And then remember, it goes like this, okay? You just multiply like that, bring the exponent down. That's negative 50 to the 1 minus x. Subtract 1 from the exponent, so that's negative 11. But what else do you have to do? Derivative of what's inside, so what's the derivative of 1 minus x? Negative 1, right? Okay. Then what you would have is you would have positive 50 times 1 minus x to the negative 11, like that. Okay, that's one way to do it. If you did the quotient rule, you get the same answer. And if I wanted a positive exponent, what would you do? You would just bring it down the bottom and write it like that. That just depends on what I'm asking for. If I don't say write as a positive exponent, then you don't have to. Okay, so those are either of those two right there, okay, right? Okay, so that's quotient rule, that's chain rule, right? How about the next one? Product rule. This is a product rule, but it'll have a chain rule in it. So, you want to make sure you know the product rule. I hope by now you have the basic rules memorized, like the quotient and product rule. I would hope by now, because you sure have done a lot of derivatives this semester, right? Okay, so we're going to do that in the product rule. So we go y prime, you write down the first, then you do the derivative of the second, and again, you can do this in your head. Okay, so when I do the derivative of the second, it's a chain rule, so it would be 3x squared plus 2x to the second. Then what else? Derivative of the inside part. Okay, so you got to do that. So that will end up being 2x plus 2, like that. Now that's half of it. That's the first times derivative of second. So this part right here is the first. This part right here is the derivative of the second. Okay, then you just do everything backwards. So now you do the second, x to the second plus 2x to the third, and then you do the derivative of the first, which is 1. Okay, so that would be kind of your unsimplified derivative right here. So again, this part right here is the second. That part right there is derivative of first. Okay, so it's like that. All right, that's how that goes. Now, the other thing that I like you to do on this is be able to factor this, okay? So if you look at this, the factor that I see that's the same is, and this is really the only thing that is the same, is this and this. Those two things are basically the same, aren't they? So which one comes out, the one to the second power or the one to the third power? Second power, right, the lowest exponent. This is, I think, where students struggle a lot, but this is kind of a good thing to review. So we have x to the second plus 2x to the second, then draw a big bracket. And you got to see if you can process this in your head. Now, essentially, one thing you can do is if I kind of block this out, okay, well, then what's left is this. Okay, so what you'd end up having is, and it doesn't matter what order you put it in, you'd have 3 times x plus 2 times 2x plus 2, like that, okay? And then the next one would go like this, okay? Well, this thing, you couldn't just block it out. You would have to have one of those. So it'd be x squared plus 2x to the first. Then you'd have the 1 left over, which you don't have to do, okay? So you got to make sure that after you get that factored, that everything multiplies out. Okay, that's the hardest part of that problem to me, is students tend to, by the end of the semester, do a pretty good job with doing the derivative, but not as good as I would like on the algebra part of that, all right? Now, what you would do from here is you would just have to simplify the what's inside the parentheses. So you would have this, And you got to work all this out. Okay, well, you'd have to FOIL this. So that would be 2x squared plus 2x plus 4x plus 4. That's the FOIL. And then this over here would just be x squared plus 2x. You don't need the first power on that, of course. So you'd have that. Then you'd collect like terms. So that's x squared plus 2x to the second. Okay, then you just collect, you can distribute, so that would be 6x squared plus 6x plus 12x plus 12 plus x squared plus 2x. Got a bunch of like terms to put together, then you're done. Okay, so let's see, like terms. 6x squared and x squared is 7x squared. 12 and 6 is 18, plus 2 is 20. And then you got the plus 12. That's a lovely problem. Okay, to me, if a student can do that algebra, then I feel like they've gained a lot during the semester. That's a good algebra problem. Okay, that's the reason I like to keep kind of giving that and going over that for students, mostly because of the algebra part. Okay. All right, any questions? Okay, I'll leave that up there for a second, and I'll post all these solutions after class, and then I can let the video run too, and I can post that. So let's see. Let's go to page 7. Let's go to the next page. Let's do a couple of these. I do want to kind of get back to limits and everything, because we haven't done that in a long time. Okay, so I want to just do D and E because they're pretty easy to do in your head. So you want to know the derivative rule for E and for Ln, okay? So what do you do if you're doing a derivative of just e to a power? There's two things. What do you do? In words, what do you do? Itself, then what? Derivative of exponent. See, if you learn that in words, it's easier to remember that way. So real simple, it's just itself, whatever I give you, like that, times, and you'd want to probably put that in parentheses. The derivative of the exponent is 20x minus 5. That's it. That's your answer. Okay, that's the chain rule. That's how that works for an exponential function. Okay. All right, how do you do the derivative of a natural logarithm? There's two things. What's the first thing? 1 over the function, then what? Times the derivative of that function inside. So it's chain rule, so that would just be 1 over 2x squared minus 5x. You don't do anything with that. Then you do the derivative of what's inside, which you can do in your head, so that is 4x minus 5, okay? And then, you don't really have to simplify. There's nothing to simplify on here, so it's wise to just put in there like that. That's good enough. You could factor an x out of the bottom, but you don't have to. So that's it. Those are two simple rules that you want to make sure that you go over. Exponential and logarithms in business and economics turn up more than anything else, actually. So to me, it's pretty important to know the rule for logarithm and exponential. You don't have to worry about this. Remember, we did like log base 5, and we did like 5 to the x. You don't have to worry about that kind of stuff. That doesn't show up very often at all in higher math, or probably what you're going to study. But ln and e to the x will. All right, let's see. How do you find average cost, if I ask you? Divide by x. Okay, so that's good. Now, you could write your answer. We usually write that as c bar of x. It would be okay if you just wrote the answer like this. There's nothing wrong with just writing the answer that way, but the reason I've been doing more with it is because if we do the minimum average cost, you got to do the derivative. And instead of doing the quotient rule on the derivative, it's better to just split it up. So you would have 1,000 over x plus 5x over x, and then 0.1x to the second over x like that. So it's probably best to write this as 1,000 x to the negative 1 plus 5. One of the x squareds cancels out there, leaving you 0.1x. So you can write the answer to the cost function either that way or that way. The second way is the way you need to do for the next step in the problem. Okay? So that's that. If a student doesn't know how to do average cost, I'd be deeply concerned. Okay, even give you a note card. Okay, how can you not do that? Right? Okay, now the derivative. So what we do now is we do C bar prime of X. Again, I'm asking for the minimum average cost. Since you're doing a minimum, you do the derivative. So the derivative would be negative 1,000 X to the negative 2. Derivative of 5 is 0. Derivative of 0.1 X is 0.1. So you got that. What do you do with that derivative? Same old thing. Set it to 0. Solve for X. Okay. So again, we just have 0 equals. And to me, I like to kind of write this then as negative 1,000 over X squared. Like that. It's a little better to handle it that way. And then you can move this to the other side. There's several ways you could solve this equation. If you did it this way, you would have 1,000 over X squared equals 0.1. Okay, now what? Probably cross multiply. Okay, that's probably a smart way to do that. You have a proportion, so if you did that, you would have 0.1 X squared. 1,000 times 1 is 1,000. Divide by 0.1. Okay, and what you'd end up having is X squared equals, I think on your calculator, that's 10,000. Is what that is. Then what? Okay, square root. So that would be 100. Okay, now that's X. Is that a cost? That's not the answer to the problem. That is how many items produce the minimum average cost. So how do you find the average cost? What do you do with the 100? Well, you got to plug it into your cost function. Okay, so the cost function, you can do this. You can use that if you want to. So what you would do is if you do C bar of 100, and you can do this totally on your calculator, it's 1,000 times 100 to the negative 1, and then plus 5 plus 0.1 times 100. And again, you can just put that all in one step on your calculator, and that gives you the cost. You have to pay attention to the directions. Cost is not 100. It's the money amount. So I can just go like this, 1,000 times 100 to the negative 1. You can do it this way if you want to. And then plus 5, and then plus 0.1 times 100. Okay, $25. This is the same problem that was on test 3. So it's $25 the answer, not 100. Okay. All right, so you got to pay attention to little details like that when you do that. All right, so that's minimum average cost. You want to make sure you know how to do that. While we're on this page, I want to do 11 and go through that because of the derivative. And another big thing that we learned how to do a lot was take a function, determine where it increases and decreases, and where it's concave up and concave down. That's another big deal that you want to make sure you know how to do. Okay, all right. So let's do the problem 11 down here. I didn't do that, did I? I think everything's getting a little messed up on here somehow. Okay, so if I give you a function and I want you to determine where it increases and decreases with calculus, what do? First derivative, then what? Critical point, set it to 0, then what? Sign chart. Okay, sign chart. All right, you can check with your calculator, but with calculus methods, that's what I want to look at. Okay, so I'm going to do the derivative over here, and this derivative is a quotient rule. Okay, so I want to go through the quotient rule on that. So that would be the bottom times derivative of top. The derivative of top is 6x. By now, you should be able to do a lot of pieces of the derivative in your head. Then the top, 3x squared plus 2, times derivative of bottom, like this, and all over the bottom squared like that. Okay, now you want to get that in the quotient rule, and then we want to simplify that down as far as we possibly can before we set equal to 0 and worry about the sign chart. Okay, So what I'm going to do, probably the simplest way is just distributive property. So I would have 6x times 6x squared is 6x to the third. Then I would have minus 54x. And you've got to be super careful with signs because it'll mess the rest of the problem up. So that is 6x to the third, but it's minus. Okay, the next one is 4x, but it's also minus because of that minus distributing through like that. And then the bottom squared would be x squared minus 9 to the second like that. Okay, be very careful with your derivative, double check it, make sure it's right. So what happens here is that crosses out. So I'm left with, it looks like negative 58x over x squared minus 9 squared. Okay, now what you got to do on this now is your critical points. This would be the part of the problem that I think a lot of students might mess up on. This problem has 3 critical points. Okay, what you always want to do is 2 things. Okay, you want to set this equal to 0. And you can do this in your head. You don't have to do everything I'm doing on here. I just do this because sometimes students aren't clear how you do it in your head. Well, you got a fraction. Okay, so if you multiply both sides by the denominator, that will clear the fraction, and it'll give you the equation negative 58x equals 0. So the solution of that equation is x equals 0. So that's one of your critical points. And you can do that in your head. If your answer is a fraction, derivative is a fraction, you're figuring out what makes the numerator 0. Okay? There's 2 other critical points though. Do you know what they are? Look at the denominator. Remember, critical points are also where the derivative is undefined. So you would have to figure out what makes this equal to 0. You don't have to worry about the square, the fact that it's squared, that doesn't matter. Now you can either solve this by factoring or you can do this. You can do square root property, so you would end up getting x is plus minus 3. So you actually have 3 critical points. And every one of those critical points could be done in your head. I wouldn't care if you did that in your head. So what you'd end up having then is it would kind of go like this. On your sign chart, you'd want to put all this in order. And like this, you got 3 critical points, so it goes like this. You have negative 3, you have 0, you have 3, and there's no derivative at negative 3. There's no derivative at 3, but there is a derivative at 0. Okay, so that's just where the derivative is 0. Now that's important on the problem because the function's undefined right there. There's vertical asymptotes right there. Okay, now when you do your sign chart, remember what you're doing on your sign chart is you're taking your derivative, which is negative 58x over x squared minus 9x squared, and then you're doing test points. Okay, try to do as much as you can in your head. Just pick a test point. Over here, I'm going to do negative 4. Okay, you can take shortcuts if you know what you're doing. So you would just be doing negative 58 times negative 4. Now, here's the way I would do this. It's over something squared. What happens when you square a number anyway? Don't you just get a positive? So you don't have to show that you're plugging the negative 4 into the denominator if you don't want to. I mean, you do that if you need to, but it saves you time. So the thing is, you're going to have a positive numerator and a positive denominator, therefore you have a positive result. Okay, if I see that the denominator is squared, well, I know it's positive. I don't have to worry about it. Okay, then I'm going to do the same thing from here. I'm going to do like, say, negative 1. So I do negative 58 times negative 1, again over something squared. All right, that's the same thing. It's a positive numerator, positive denominator, so it's still positive, like that. Okay, then I move over here, it'll change. I use a test point maybe of 1. So negative 58 times 1 over the bottom squared, that's a negative numerator, a positive denominator, therefore it's negative. Same thing will happen when you go past 3. If you go to 4, it'll be negative 58 times 4 over a positive denominator, so now it's negative over positive, so it's negative. Okay? Whatever you need to do, if you can do shortcuts, that's fine. Okay? You could even graph the derivative and trace out if you had to. Okay? So anyway, how do I know where it's increasing? That's where it's positive, right? Okay, so you would basically be increasing here, increasing there, and you would be decreasing here, and you'd be decreasing there, okay, like that. So that means you'd write your answer like this. You would say you're increasing from negative infinity to negative 3, union negative 3 to 0. You can't put that in one interval because the derivative doesn't exist at negative 3. So it has to be broken up into 2 spots. Okay, as far as decreasing, that would be 0 to 3, union 3 to infinity, like that. Okay, so again, the key is effectively getting your derivative critical points in the sign chart. Now, the local min and max, you've got to be really careful about this. What's basically happening on this problem is this. You basically are increasing. So this graph is doing something like that, and that's a vertical asymptote. You're undefined at negative 3. Okay, you're increasing here, so the only way that this could look would be something like this. The graph would have to go like that. Then would have to just increase like this. Then it would start decreasing towards that asymptote like that. And then over here, what would happen, this is an asymptote, so the graph would kind of, whoops, that's wrong. So it would have to go kind of like this. Okay, and again, all this stuff I'm doing right now could be checked on your calculator. You got a calculator that you can use. So you would see the graph kind of doing something like that. Then you would see the graph doing something kind of like that. Okay, so do I have a local minimum? No. Do I have a local max? What is a local max? It's a point on the graph where the graph increases, then changes directions. Does that happen? Yeah, it happens here. So you do have a max there. So we just say local max x equals 0. Local minimum, we don't have one. Okay? Now the thing is, I'm not going to take the time to do this, but as a student on a problem like this, couldn't you just graph the function and make sure you're on the right track? Absolutely. So do it. Even if I don't ask for the graph, you should do it so you can verify that that information's right. So you could actually, instead of figuring out how the graph goes, you could put it in. And that would help you to make that determination. Okay? So the biggest part of that problem to me is, number one, getting the derivative right, and then being able to fill out that sign chart. That's it. Study that. Okay, let's see what we got time for here. I hadn't talked a bit about limits. So let me go back kind of the beginning and let's see what we need to do on a couple of things with limits. Let's do L'Hopital's rule and let's do just some graph stuff. I remember back, when we were at the beginning of the semester, when I gave graphs and doing limits, that was problematic for a lot of you. So, you want to make sure you study that. Let's do L'Hopital's rule on this page 3 and just kind of remind ourselves how to do some of these. And then we can look at maybe some of those graphs where you're doing limits, because we haven't done that in a long time. All right, so basically when you're doing a limit, you always want to plug in the number I give you. So like this would be negative 3 squared minus 9 over negative 3 plus 3. You want to do that, okay? So that would be 9 minus 9 over 0. So that form is 0 over 0. Now, if you have a 0 over 0, you can do L'Hopital's rule. Way back at the beginning of the semester, before we learned L'Hopital's rule, you factored and tried to work it out that way. To me, L'Hopital's rule is just as easy to do it this way. So what do you do on L'Hopital's rule anyway? You do the derivative of the top, derivative bottom, and then you try again. Okay, this one's pretty easy. Derivative of the top is 2x. So you'd have the limit. X goes to negative 3 of 2x. Derivative of bottom is 1. Now you try again, and it'll work. So now you just plug in the negative 3. So 2 times negative 3 is negative 6. Okay, and by the way, if you had time on this, you could quickly graph that on your calculator and see that it's right visually. If you did that, you can tell you're right, but I would want to see the work on your paper like this, okay? The next one would be kind of the same idea. Plug in the negative 1. You'd have negative 1 plus 1 over negative 1 squared minus 7 times negative 1 minus 8. So that is 0 over 1 plus 7 minus 8. That's 0 over 0. Okay, so you just need to make sure that you're paying attention to that. Since it's 0 over 0, then you can apply L'Hopital's rule. Okay, so you would end up having derivative of numerator is 1. Derivative of denominator is 2x minus 7. Try again. I think it'll work. We did problems in class where sometimes you did L'Hopital's rule 2 or 3 times. That could happen theoretically. But if it doesn't, then you just try again. And this would be 1 over 2 times -1 minus 7. So that looks like 1 over -9, which is okay to write the answer that way. It's just a -1/9. Okay, like that. Okay. L'Hopital's rule, just, you can do that, okay, if it's a 0 over 0. Okay. The third example I want to look at here is when you have an infinity in there. So if you plugged in infinity, you would have infinity to the 3rd power over ln of infinity. Well, what form is that? The numerator is just getting infinitely big, right? So is the denominator. If you do a log of a bigger and bigger number, it just gets bigger and bigger forever. All right? So can you do L'Hopital's rule? Yeah, there's 2 times we learned you can do that. That's if it's 0 over 0 or infinity over infinity, okay? And this one would be really hard to do if you didn't know L'Hopital's rule. So what we do is we do the derivative of the top and the bottom. Okay, so the derivative of the top is 3x to the 2nd. What's the derivative of the bottom? Okay, so that's it. Now, what I see students on a problem like this, the algebra falls apart a lot of times. What you're doing with this is you're really just doing 3x squared divided by 1 over x. That's really what you're doing. When you divide by a fraction, what do? You flip the second one upside down, so you get 3x squared times x over 1. So that ends up giving 4x to the 3rd. 4, no, not 4, 3x to the 3rd, like that. Okay, so by simplifying that, you would have limit x goes to infinity of 3x to the 3rd. Now you plug in and see what happens. Okay, so what you would have is 3 times infinity to the 3rd. What is that? That's just infinity. It's okay for the answer to be infinity. It is. What you would find on this, if you graphed that on your calculator, you would find as x gets big, so does y. That's what would happen. So you can verify visually that you're correct on any limit with your graphing calculator. See? Okay? All right, does that make sense? Okay. All right, well, let's go back to this first page and just do a couple of limits. I'll post all these things. It shouldn't take me too much longer to finish up the rest. We got through most of them. But these kind of things, let me just kind of review what we have time to do here. So what I'm asking on the first row is function values, right? So like f of -1, if you look at -1, that y value is 1. You know, you want to study what these problems mean and everything. If I say f of 0, I'm looking at x equals 0, what's the function value? Is there a function value with a bubble there? No, so you just say like undefined. Okay, f of 1, you're looking at x equals 1. Is there a function value at x equals 1? Yeah, there is, right there. There's a solid dot, so that's 2. Okay, that's how that goes. The next one's f of 3. Is there a function value at 3? Yeah, that's 0. So those are function values, okay? Now let's look at these limits and study this because you need to do good on this kind of thing. So this is a right-hand limit, okay? So if you're going to the right of 0, then just get a little bit to the right of 0 and then just sort of close in from the right-hand side, okay? What is the y value getting close to? 2. It doesn't matter if there's a bubble there. The limit is what the y value is getting close to. Okay, that's why. So if you're going from the right of 0, you're getting close to 2. Okay, how about the next one? What kind of limit is this? Left hand. So if you go to the left until you get to x equals 0, where's the limit going? 2 again, right? Okay, the next one's a 2-sided limit. So are they both going to the same place? Yeah, so that's kind of what we learned there. That's a very fast review. But work out the rest of those limit problems, and I'll post the answers. I got plenty of time today just to go ahead and get this out of the way pretty quick. And I'll post the video. And if you study over this, you should be in really good shape. Okay?